Hello everyone, this is Dr. Song. Thanks for visiting and watching my YouTube videos. I didn't post about 2 weeks my YouTube videos about the quantitative research method. I was in South Korea and I visited my family, so I had some break. And now I came back, so I will continue to publish the YouTube videos. From the last time, we stopped in the more advanced approaches. So let I start here. As usual, I provide the references from what courses I got the materials to construct my course. So these are the professors in the University of Ottawa, and I studied quantitative research methods from them. Since last session, yeah, I started to show you what are the more advanced approaches in the statistics. So the inferential statistics. So we saw some basic for analysis. That is a chi-square correlation and regression, simple linear regression, and also the t-test. I didn't introduce the ANOVA. Yes, I think I introduced the ANOVA last time. So that is like a prolongation of the t-test, uh, but they have the more than two groups. In that case, you can use the ANOVA. And then basically in ANOVA test, you compare the means of each group, and then that is compared by the grand mean, and then you can also calculate with the residuals, and there is an ANOVA table that provides that the mean is significant or not. And finally, when you have the significant result in the ANOVA, and then you can do the post hoc, that is where exactly the difference happens among three or four groups. So that was the ANOVA test. And today is a factorial ANOVA. There is a more advanced approach in ANOVA. So normally you have the one independent variable, categorical variable that contains the more than three groups. But in the factorial ANOVA, we call also two-way ANOVA, and the predictor, they have the two categorical variables and the one continuous variable that is dependent. For example, here, as a program of study, communication, public relation, and journalism, you can see that there are three groups in the one variable, and the sex is a male, female, there are two groups. So these are two independent variables, how they affect the continuous variable influence the total number of people followed by Instagram, the number. So the total number of the people followed in Instagram, how these two independent variables affect that result. So that is the factorial ANOVA. Factorial ANOVA is interesting because it's not only about the one variable effect and then second variable effect. You can also obtain the interaction between the two. So interaction between the program of study and then the gender, you can also find the interaction effect on the continuous variable. So that is an interesting thing. So here, in order to know the effect of each independent variable A and B, in this case it was the program and then the gender, and also you have an interaction that is between a gender and the program. We can find in the factorial ANOVA. So this analysis examines the differences between the mean scores of the one continuous variable. So that is Instagram posting, Instagram followed people based on the two categorical variables, and whether these differences are statistically significant. So each categorical variable must have the two or more groups. So that is about the ANOVA. So you will find in the result different programs that changes the follow the number in the Instagram, and also the gender also, and also the program and then gender in the interaction, that also makes the difference about the dependent variable. So that is about the factorial ANOVA. JK ANOVA means that J is the number of groups in the first independent variable, So that is about the programs. So it's here is 1, 2, 3, and then the gender is 2. So here the K is the number of groups in the second independent variable. So gender is a 2. So for instance, the 3 and then 2 in this case, 3 and 2 ANOVA means that 3 groups and then 4 groups, they are participated in this um, factorial ANOVA. So you will say that that is the relationship with the JK ANOVA means that. And then advantage of two-way ANOVA, instead of two ANOVA analysis, it can be once. Okay. So instead of doing the programs and then follow the number of the Instagram, and the second analysis is a gender and the followed Instagram, you can combine them is only once, and you can run the only one analysis to find that result. And then to examine where there are significant differences in the mean score of the dependent variable between the groups of the one independent variable and the second one, and also the interaction between them. So this is the advantage of the two-way ANOVA. And that's another more advanced approach in the inferential statistics is the multiple regression. So the simple linear regression is that one independent variable that predicts the dependent variable, how that can be changed. So, for instance, here only one simple linear regression can be hours on social media that predict the total number of people followed on the Instagram. So if you have only one continuous variable, that is simple linear regression. So only the one independent variable that predicts the total number of people. However, when you have the second or third or fourth, you can put the multiple predictors, and then that becomes the multiple regression. So in this case, they added the self-esteem, that is the continuous variable, and then that is also influencing or predict the number of people followed on the Instagram. So you will obtain the variances of each independent variable, how much percent they contribute about these differences. So the social media, how long you use the social media, and also the self-esteem of each person, and then that predicts the total number of people followed on the Instagram. So the multiple regression is an extension of the simple linear regression, and this is widely used in the social science research and also in the many different business, like for instance, stock market. They want to predict what influenced the stock market benefits, etc. They use all these cases in regression, multiple regression. Most use the advanced statistical technique in the social work research. Examine the effect of multiple independent, that is a factor, predictors. You can have the 1, 2, 3, 4 as much as you can. And only one independent variable. That is a criterion, is a Y outcome. So your outcome is affected by the factors, that is independent variable. And then also you will obtain the variances of each factor. Estimating the model of the multiple factors has the best predicts the criterion. So we use the ANOVA table for that, aim to predict the level of outcomes so that we can see how much depression, anxiety, empathy, etc. that outcomes depending on what kind of factors it can be predicted, it can be influenced, we can find. So, for example, what set of following factors best predict level of depression among welfare recipients? So, there is a one factor: age, marital status, race, level of education, number of years of on welfare, and the physical health and the social support. These are all factors, and then that affects your outcome. Your outcome you can determine what can be, for instance, depression, anxiety, empathy, etc. So researchers want to know which set of these factors best predicts the depression. So your outcome dependent variable will be your depression. So all among those factors, you can find which one is the best predicts the depression, because you will have the you will have the regression R, and then when you have the how can I say that is R2. So R square, R square, and then you can find the how much percent of each predictor that predicts the depression. So it helps the practitioners to plan intervention and the prevention strategy for them. Okay, so when you find the factor best predicts the depression, and you can find the solution, or you can prepare the your intervention to avoid the depression. So with all this information, now we should know which analysis we have to take. So this process, decision process, can be look at your research question. So your research question is you wants to know about the relationship, or you wants to know about the influence and the prediction. That depends on the that makes you determine the which process, which analysis you take. Confirm the level of measurement of the variables. Of course, this is very, very important, because even though you want to run the regression analysis, but if you don't have the continuous variables, you can't. So that is really the one of the most important factor to decide the which analytics. Make sure research design supports the type of analysis. Statistical test assumptions are met. Okay. So the second part, assumptions, yeah, that is also important, because if you want to run the normal analysis, not the non-parametric, parametric means that assumptions are met. They should be met to run the parametric test. So that is important point you have to consider. And then the research design supports the type of analysis. That is related to the your level of measurement of variable also. So these are the all important to decide the which analysis you can take. Okay, so we can stop today here, because from the next session I want to go the more details about how you can decide the analysis, which is the most proper for your research design and then your research question. So thank you so much for listening to this session, and then I will see you in 1 week. Thank you so much. Bye.